The students start with a new session. In this session, we are discussing about the ultimate approach to the sampling theorem. Let me write it in short. Sampling theorem in time domain. In time domain. That is TD. Okay, let's. This is what the x of t is, continuous time signal. Next is nothing but the s of t, as we have seen earlier also. S of t, delta of t minus nts. This is what, let's say, the format for s of t is ts, 2ts, 3ts. Likewise, it is extended. Next, at the negative side, it will be minus ts, minus 2ts, like this. When we multiply x of t, this sequence, with this s of t, we expect result as a x delta of t. So that is what here. X of t into s of t, x delta of t. In equation format, it will be like summation n is equal to minus infinity to plus infinity x of nts into delta of t minus nts. Ts is nothing but the sampling time. So it will result in this kind of nature. So this is nothing but our x delta of t. Okay, that means this particular sequence. So it is resulting in sampled format, in short. When we multiply this sequence with this, it will result in a this kind of waveform. Now, Fourier transform of sampling function s of t is s of f is equal to capital S of f, that is equal to fs, sampling frequency, summation n is equal to minus infinity to plus infinity delta of f minus n fs. This is nothing but the Fourier transform of s of t. Therefore, x delta of f is equal to x of f involved s of f. This is what earlier we have seen. When we multiply two time domain sequences, it will result in a convolution in frequency domain. Now, this is what the x of f. Let's take it as it is in the next step. Replace the value of s of f in this particular equation over here. This value will become fs into summation delta of f minus fs. Once this is done, let's rearrange the term. The rearrangement, it will look like here fs times summation n is equal to minus infinity. This is where the convolution is taken. It means only the terms related or related to the frequency are taken over here, which is based on the value of n. Okay. So this is how the summation is simply rearranged. After rearranging it, it will further be explained like x delta of f is equal to fs times summation n is equal to minus infinity to infinity. Let's rearrange it. So this convolution will result in a factor, that is x of minus nfs. How it came? This equation 1, how it came? It is because of this reason. When message signal spectrum convolved with shifted impulse function, it results in shifted function. So that is what done. So message sequence convolved with shifted impulse function, it will result in a shifted function. So that is what done over here. Now the same equation 1, this can be written as x of x delta of f is equal to fs times x of f. Is rearrangement of this particular term. This is where only the n is equal to minus infinity was the picture. We can just observe over here n is equal to minus infinity to plus infinity. This term I will split like fs times x of f is at the 0 instant. So this is specifically at n equal to 0 plus. What about n not equal to 0? So minus infinity to plus infinity when n is not equal to 0, fs times x of minus nfs. So let's call this as the equation number 2. Once we got the equation 2, it is quite clear, or rather concluding statement, that from equation 2, uniform sampling of signal in time domain results in periodic spectrum of frequency domain with period equal to sampling rate fs. Period equal to sampling rate fs. So that is all about the alternate approach of sampling term in time domain. In the next lecture, we are going to look for the statement, that is find out whether the sample sequence x delta of t completely represents x of t. Now, how to correlate these two? For this one, the simple idea is, let's calculate the spectrum for x delta of t and calculate the spectrum for x of t. Compare these two spectrum. If these two are matching, it means sample signal, that is x delta of t, completely represents x of t. So this is what the proof which we are going to study in the next session. Thank you everyone.